We're going to look at one-way analysis of variance. So what analysis of variance does is compare sample means in these different, for a treatment. So we have 4 categories, but one treatment, because the treatment has to do with the size of the car. So we just have 4 categories under that one treatment. So that's why it's a one-way analysis of variance. And what we're going to do is look at the variance to see if the sample means are the same or not between each of these categories. So the null hypothesis is that these population means for each of these categories are equal, and that means the alternative is that at least one of them are not the same. We're going to use some software to calculate a couple of different standard deviations. One is the standard deviation within each sample itself, and we're going to compare that to the standard deviation, or the variance with between all the samples. And when we're comparing, we're using a ratio, right? A ratio of variance So when we use a ratio of the variances, that's called an F-test, and we learned that a couple sections ago. So that's what we're calculating, is a test statistic that's actually an F-test. So let's talk about how to do that using our software. The first thing we need to do, StatCrunch won't do this for us, so we need to use Excel, and we need to make sure the appropriate things are added in. So we hit this funny looking Windows icon up here, and then we go to Excel options. Go to add-ins, and then we need this analysis tool pack to be added in. So you highlight it and then hit OK, and it should add it in for you. The way you know that it's added in is that you'll actually see it up in the menu bar. Somewhere up in here, I think right there, we should see, if you go to data, right here it says data analysis, and we want to make sure that it's loaded that tool pack in for us. Okay. So the next thing we're going to do is go get our data. So we click on it and copy it to our table or a clipboard, and open up Excel, and then we paste it. To do that, I just right click and then hit paste. So that takes each of those 4 categories and puts it in Excel, and then what we need to do is go hit data analysis, and we're doing a one-way ANOVA, which Excel calls a single factor ANOVA. That's what one-way means, is one factor. So go ahead and click OK. Input range, that's going to be the data here. So we can just highlight it, and then once it's highlighted, we make sure that we tell it how it's grouped. This one is grouped. Each category is in its own separate column, so we're going to make sure that the columns radio button is clicked. And then we need to make sure our alpha, our significance level here, matches up with that in the problem. Yes, we're using the same significance level. The output range, we're going to select that. We're going to have it put the output from all the calculations and the analysis in the spreadsheet itself, and we want to tell it where. We don't want to rewrite over our data that we already have here, so I'm just going to select down below, and we'll hit OK, and then it does its calculations and puts its output in the same table below. So here's what it calculated. It told us that the variation between the groups was this amount, and then the variation within the groups was this amount. It divides the two, it compares them, and comes up with this F statistic right there. We know that that's a really, really high F test, or test statistic, especially compared to this critical value, and so we're going to reject the null. Also, this p-value is really small compared to alpha, the 0.05, and so we're rejecting the null. When more of your variance comes from between the groups, what it means is that these variances between those groups is larger, which means the mean of one of them is different or larger. So a large F-test means that these categories are more dissimilar. Okay, so let's answer a question here. Should the null hypothesis be rejected? Yes, the p-value is less than significance value, or significance level rather. Do the data suggest that large cars are safer? Yeah, because we're rejecting the null hypothesis. So that data suggests that the mean deceleration for the large cars right here is smaller than for all those other cars. So we say yes. All right, I hope that helps you use Excel to quickly do a one-way analysis of variance. Let me know if you have questions.